Today I am building a mystery circuit. It's going to be part mystery circuit, part op-amp tester. I got a whole bunch of op-amps here that I suspect are all bad. Well, all but this one. You can pretty much figure out why that one there wouldn't be bad. But I think all the rest of these plastic dips are all bad. There's a couple in here that came from Mouser Electronics that I think are bad as well. There's a CA3130E in there. I know that one's not bad because I know where that thing came from. It says RCA on it. That kind of tells you something. It's got Hisol on it, so that tells me it was part of a high voltage board that I had built at one point in time. So this is going to be a dual purpose board. Now, as with most projects, everything revolves around the shoebox. This kind of shows you what my shoebox looks like. So we need some wire wrap, obviously a good working CA3140, and it's got a pretty high count as far as pots go. Should be a 10 in there, a 20, two 500s, two 4148 diodes, three 10K 1%ers, 30K, a 0022, two TO5 sockets with a 2N2222A and a 2N2907 in them, and a piece of very old phenolic circuit board. Now this mystery circuit is going to have two more op-amps to it at some point in time, so it's going to be a three-step mystery circuit. I'm not sure that I'm ever going to get two more op-amps and the rest of the circuit on there, but we'll give it a go. Let's get her done. You know, I say this all the time when I build circuits. When you stick that first component down, you're committing to a lot of things, and you sometimes don't do yourself any favors about where you stick that first part. So we need a 10K from pin 3 to ground. We need a 10K from pin 3 to something else, and since these are so small, I can shove them all down in the same hole. And we're going to shoot that one that way because that's going to go to VCC. And then this 10K resistor here, we're going to cleverly shove right over here on the side. And once you build about 1,000 boards, you do kind of learn how to utilize spaces around an IC socket. So that one's going to go to pin 6 and pin 3. So it looks something like that. I am sorry, but I may have to shut some of these lights off because I don't think I'm going to be able to do this with this much light on. So then a cap goes from pin 2, right here, to ground, right there. Now we also need pin 4 of the op-amp grounded. I've never used wire wrap strippers. Well, I can't say that I've never used wire wrap strippers. But over the years, I've worked with wire wrap so much. Honestly, I don't even need them. I could sit here and strip wire wrap all stinking day long with these things and never nick it, never cut it accidentally or anything, really. There we go. Pin 4 is grounded. I need a 30K that's going to go from pin 6, and that's going to go to a whole bunch of crap here. So we want to shoot that in a direction where I got some room on the board. I think I'd do better off shooting this resistor in that direction, because I think I'm going to end up falling short on space if I don't. I'll stick that 20K pot there. So this pin and this pin on that pot needs to be tied. Kind of like that. Now the end of this pot is going to go to another pot, which is a 10K. It's going to go to the wiper of that. Try it like that and see if that works. So there's the wiper, and there's the end of the other pot. Kind of like that. Now the ends of this pot here are going to go to two diodes. One going one way and one going the other. Kind of like that. Everything was going fine until I met up with these Milmax sockets. Wow, what an absolute piece of junk. So obviously I'm not going to get two more ICs on this board. But I got the 2222A and the 2907 on, and those two 500K pots. The bottom of those pots go to ground, the top of the pot goes to VCC, so you can see I just kind of tied the two together there. And then the wipers of those pots are going to go to the bases of these two transistors. Alright, there she is, just like my favorite Tube song. She's a beauty. So if you want to try to earn your master's degree today in being psychic, what did I just build here? I stuck an 8-volt regulator on here. So power comes in here, ground goes in there. I stuck this on it because I have a feeling we're going to need room for expansion. I didn't want to make it completely impossible for somebody to figure out what it is. But there is one thing on this board that should be somewhat of a clue as to what this is. I think that'll be relatively safe like that. Now, I don't know. There's no guarantees here, man. I am having some serious vision issues today with inability to focus on stuff. I mean, really, it's every day, but today is probably 3 times worse. So there's always a distinct possibility that I missed something. I would be amazed. I really, truly would be if this thing works. Because that's just how fast I did it. Oh, this fluorescent light in me is not getting along because I am literally blind from it. 200 millivolts per division. Try to focus a line that doesn't focus. Well, let's turn that to 50 microseconds. But I just can't see with that light on. Matter of fact, I really can't see anyway. Worst case scenario is nothing's gonna happen. Uh-oh. Uh-oh. That don't look good. Ain't nothing happening. That's what I wanted to say. Could be a million possibilities here. Alright. I think it's actually good that this happened here. Somewhere on this board something isn't right. So I want to show you something here about op amps. If you know nothing else in the whole entire world about op amps, know this. An op amp's whole purpose in life is to make its input terminals equal. That doesn't always mean that they will be, but the op amp will always try to make them equal. Now in this amplifier here, here's the voltage that I have on the pins on it. Well, there is feedback from the output here back to this pin. Well, the output is low because pin 2 is greater than pin 3. So the op amp itself is doing exactly what it's supposed to do. It's trying to make its input terminals equal, but it just can't do that because something is not right on pin 2 on the non-inverting input. That is the Rosetta Stone of op amps. It always wants to try to make its input terminals equal. This voltage here actually is not correct either, and the reason this voltage isn't correct is because this voltage isn't correct. There's also feedback on here too. So the reason I'm seeing 2.76 on the non-inverting terminal here is because the output of this is pulling this low through another resistor. So somewhere on this board there's a mistake, and I'm just not sure where it's at just yet. But this is kind of a troublesome board here. I try to stay away from these because the pads are so close together. It's mainly the IC pins using these piece of junk Milmax sockets where you run into problems with shorts being in between the pins. As funny as it sounds, oftentimes I find if I'm trying to fix something and I just can't fix it, that's usually a sign that it's not broke. And you know, you might laugh at that and say, man, I don't know what to say about that. I mean, there's a lot of truth to that. I see that all the time with something. So here I am going back and forth over this in my head, and everything was absolutely correct with it. So all I had to do here was tweak a couple things. and she just started purring. So here's the pot on my NPN, and you might notice what's happening there. Now here's the pot on my PNP. Look at that. You might notice what's happening there too. Bingo. Look at that. Take a gander at those apples. 121.5 microseconds. About 139 microseconds. So I got to do a little bit of tweaking on it yet, but it's a pretty symmetrical triangle wave. Now who would have thunk that you could get a pretty symmetrical triangle wave out of this circuit that I just kludged together here? Let's turn the frequency pot and see what happens. Pretty neat. Just needs a little tweak here and a little tweak there. Hey, you don't have to tell me that I need help. I've known that for a long time. I'm sure everyone's dying to know, what the heck did I build? Well, I pretty much told you what I built. I just didn't show you the schematic for it. The reason I didn't show you the schematic is because I don't have one. So anyway, I'm going to have to draw this out. So all you inquiring minds out there will know how you get a symmetrical triangle wave out of an astable multivibrator. Not even your AI girlfriend can tell you that. So kind of funny thing that probably may not sound so funny, but if you knew me, you would honestly know why it's so funny. If you would like to contribute to my channel, please send a whole skid full of these yellow tablets. This is an astable multivibrator, kind of with a twist to it. Kind of interestingly, I've never seen this schematic anywhere on the internet. This is something I came up with many years ago when I was experimenting with building some function generators. It makes a pretty nice triangle that has pretty decent linearity to it. Normally we would see a charging and discharging waveform like this. I kind of over exaggerated it here. It's more like that. So it's kind of like a log, reverse log taper on the charge and the discharge of this cap. But once you add in the transistors and keep more of a constant current to charge and discharge the cap, it becomes a pretty nice triangle. Honestly, I think these pots here should have been dropped in value, but that's what I had. These diodes don't need to be in there, but I just put them in there because I'm used to making this circuit for something different, where the diodes do need to be in there. You will see this astable being used to make a square wave output, and when you see that, you'll see that there's resistors connected back here, feedback resistors. Now it's kind of weird the way I got mine drawn because I got one on the top and one on the bottom, but I needed to do that to fit the transistors in. But normally you'll just see one feedback resistor from the output back to the non-inverting terminal. If you wanted to adjust the duty cycle of that, then you would put in the diodes. You would have a diode up here facing one direction and a diode facing the other direction with pots in series with it, and then you could adjust the duty cycle of this. If you had the resistors in here, like this circuit is normally shown, then this here pot would become the duty cycle pot. But in the case of what I built here, this is simply the symmetry pot to set the symmetry on the triangle. We get a pretty nice 2.7 volt peak-to-peak triangle out of that point there. I did make one change on this schematic. I lowered this 0022 down to a 470 puff. So if we measure from the bottom of the triangle up to the top, we're getting about 45 microseconds on that side. If I adjust the symmetry pot, you can see what happens there. So the frequency on this adjusts from 90.6, which would be 11 kilohertz, up to 60.9. So 11 kilohertz to about 16.42 via this 20K pot. Hopefully I got enough room on the circuit board to get another op amp or two on there, because there's 2 more steps to this. So anyway, hey, thanks for watching my video. You take care and have a great day. What would those AI girls think if you told them you just built an astable multi-vibrator? That AI girlfriend would probably say, that's impossible. You can't get a symmetrical triangle wave out of an astable multi-vibrator.